Hello everyone, today we are going to start our new lesson, Heat and Thermodynamics. It is a huge chapter and it is very important from physics point of view. So we are going to start our lecture number 1. So what is thermodynamics? Thermodynamics is the branch of physics that deals with the concepts of heat and temperature and the interconversion of heat and other forms of energy. So thermo means heat and dynamics is the motion. So heat, conversion of heat into one form into another form, or the flow of heat and its flow. It is basically studied and discussed in thermodynamics. So thermodynamics is basically a macroscopic science. We study thermodynamics on a macro level, not on micro level. It deals with bulk systems. Bulks mean huge system, and does not go into the molecular constitution or molecular composition or molecular structure of matter. Thermodynamics description involves the relatively few microscopic variables of the system, which are suggested by common sense and can be usually measured directly. So that's why it is very observable science. It is very everyone can feel it, because we can we can analyze, we can observe it. Everyone can observe it because this is a science on the macro level, not on the micro level. The microscopic variables such as pressure, volume, temperature, mass, and composition that are felt by our sense perception and are measurable. So that's why the thermodynamics is related to the industrial science. It is being studied on industrial scale, because in the industrial scale the pressure, volume, and temperature of composition of the matter are being discussed in detail. Thermodynamics description of a gas, on the other hand, avoids the molecular description altogether. Molecular description related to the speed of particles, related to the motion of particles, related to the more structure of the atoms or molecules. These are being avoided specifically in thermodynamics. Microscopic description of a gas, for example, will involve specifying the coordinates and velocities of the huge number of molecules constituting the gas. So I told you earlier that we are not going to study the motion of molecules or the structure of molecules in this science. It is basically related to the macro level. So that's why this thermodynamics is very important in industrial science. What is heat? Heat is basically a form of energy in transit. Transit means flow. So heat is basically a kinetic form of energy. It is energy in flow. Heat is not a quantity. Some people think that heat is a quantity, but it is actually not a quantity. Heat is basically a kinetic energy. Heat is an energy in transit which flows from higher temperature object to lower temperature object. Once the heating process is stopped, we cannot use the word heat. So when something is heating, we can say that actually the energy transferring take place. When we use the word heat, it is the energy in transit, but not energy stored in the body. So heat is basically not a stored or potential energy. It is basically kinetic energy. Now, another term which is commonly used is work. What is work? Work is basically, from physics point of view, specifically in thermodynamics, work has very significant meaning. Let me elaborate it through a common example. Suppose you rub your hand, and after rubbing your hand, you will feel the heat inside your hand. What you have done, you do work on your hand, and because of this work, heat is produced. And when you touch your face with your hand, what will happen? You will feel the warmth of your hand. Actually, you do work on your hand to produce heat energy, and you transfer this heat energy to your cheek. So you feel the heat energy because of its transference. So we can say that heat energy is basically the result of work. Whenever we are doing work on anything, physical work, as a result of this physical work, heat energy is produced. So this is very important concept in thermodynamics, that heat energy is produced as a result of doing physical work. In industrial scale as well, whenever we want to produce heat, what do? We do work on physical work on machines, and that machine produce heat energy. So by doing work on the system, temperature in the system will increase and sometimes may not. Like heat work is also not a quantity, and through the work, energy is transferred to the system. So we cannot use the word object contains more or less work. Either the system can transfer energy to the surrounding by doing work on surrounding, or the surrounding may transfer energy to the system by doing work on the system. For the transfer of energy from one body to another body through the process of work, they need not to be at different temperatures. They can be at same temperature as well. Now, what is meaning of temperature? Temperature is basically the degree of hotness or coolness of a body. Whenever we want to measure the heat energy, we do this through temperature. Hotter the body, higher is its temperature. The temperature will determine the direction of heat flow when two bodies are in thermal contact. Heat flow means that the temperature will determine that how much energy, how much heat energy is transferred from hotter object to colder object. The SI unit of temperature is Kelvin. Kelvin is the name of the scientist who first introduced this scale. In our day-to-day applications, Celsius and Fahrenheit scales are used. Temperature is measured with a thermometer. Now the conversion of temperature from one scale to another scale. We can do this through this simple scale. Let me elaborate it. Now, for example, we have three scales: Fahrenheit scale, Celsius scale, and Kelvin scale. In Kelvin scale, the freezing point is 273.15 Kelvin, and its boiling scale is 373. The difference between the boiling and the freezing scale is almost 100 Kelvin. In the same way, Celsius scale, the freezing point is 0 degrees centigrade and the boiling point is 100 degrees centigrade. And the difference between the boiling and freezing scale is 100 degrees. In the same case, in Fahrenheit scale, the boiling scale is 212 Fahrenheit and the freezing scale is 32 Fahrenheit. And the difference between the boiling and freezing scale in Fahrenheit scale is 180 degrees. So whenever we want to relate or we want to convert one scale into another scale, we can use this formula. Here, for example, there is we want to convert 134. This is the required temperature. Required temperature, and want to convert this into degrees Celsius. So this required temperature minus freezing point divided by the difference between boiling and freezing point is equal to the required Kelvin temperature minus freezing point divided by the difference of boiling and freezing point is equal to required Fahrenheit scale minus freezing point of Fahrenheit scale divided by the difference in the boiling point and freezing point. By using this important formula, we can convert any scale into each other. Now, suppose we want to convert Celsius scale to Kelvin scale. We can relate Celsius scale to Kelvin scale through this equation, and by arranging the equation, we can say that Kelvin scale is equal to degrees centigrade plus 273.15. From Kelvin to Celsius scale, again we can use this above relation as well, and this degree centigrade would be equal to Kelvin minus 273.15. In the same way, we can convert Fahrenheit scale to Celsius scale through using this relation, and by arranging the equation, we can find that degrees Celsius is equal to 100 divided by 180 Fahrenheit minus 32. And arranging the equation, we get 5/9 Fahrenheit minus 32 degrees Celsius. In the same way, we can convert Celsius scale to Fahrenheit scale by using the relation, and we can get the Fahrenheit scale is equal to 9/5 degrees Celsius plus 32. Now perform each temperature conversion. Number 1, 102 Fahrenheit to Celsius, 0 Kelvin to Fahrenheit, minus 48 degrees centigrade to Fahrenheit, 273 Kelvin to Celsius, and solution. Let's do the first one, 102 Fahrenheit to Celsius. We know the formula, and after knowing writing the formula, arrange the equation, put the value of Fahrenheit in the equation, and we will get the Fahrenheit 102 Fahrenheit to be equal to 39.2 degrees Celsius. 0 Kelvin to Fahrenheit. We can use this relation as well, and after putting the value of 0 Kelvin and arranging the equation, we equate 0 Kelvin to minus 433.8 Fahrenheit. In the same way, we can convert minus 48 degrees centigrade to Fahrenheit by using this formula, putting the value, and after calculation we get minus 28.8 Fahrenheit scale to be equal to minus 48 degrees Celsius. In the same case, we can convert 273 Kelvin to Celsius by through this formula, and doing the subtraction, we get this 273 Kelvin to equal to 0 degrees Celsius. Now let's do an example. The coldest temperature ever measured in the United States was 80 Fahrenheit on January 23, 1971 in Prospect Creek, Alaska. Convert that temperature to degrees Celsius and Kelvin. Solution. We know that conversion of Fahrenheit into degrees Celsius, the specific formula is given 5/9 Fahrenheit minus 32. Putting the value of Fahrenheit, which is minus 80 Fahrenheit, and after doing the calculation, we get this. Get that minus 80 Fahrenheit is equal to minus 62.72 degrees Celsius, and after that we can convert easily this scale into Kelvin by through this formula, and it is equal to 210.28 Kelvin. So I hope that you have understood the lecture. Stay happy, do study. Goodbye. Have a nice time.